All right, okay. Good morning, students. Okay, mic check. Is the sound clear? Please raise your hand. All right, okay. Thank you. So far, attendance, okay, 33%. Okay, one third, no bad. Okay, sorry for disturbing you during these holidays. It's straight away left already. All right, okay. So today we're going to finish our this chapter 6. Okay, it's very small chapter, radioactive. So hopefully with that we can finish our syllabus on time before the trial. Okay, because chapter 4 and chapter 5 is a big chapter. So and then the chapter 7 is new in the syllabus for the quantum physics. So that one the three subtopics, but content that you need to learn actually not that much. So chapter 7 basically we can finish earlier also. Right. So if necessary, maybe that chapter 7 I also will do it online. Okay. So depends on the progress, how is it? Because coming uh September and October I also have some activity outside. So hopefully not much class will be postponed or cancelled. Right. Okay, so anyway, so we try our best lah, huh? Okay, chapter 6, okay, only two subtopics, radioactive decay and the nuclear energy. So the content that you need to learn for in the new syllabus here, it seems like not so much. It's very, very little compared to old syllabus. But okay, there are a lot of the part that related to radioactive actually is already covered in your PD3 science. So you need to recall back. You need to recall back. Example, if I'm not wrong, okay, regarding the what is this? This one regarding all the detector. Okay, the radiation detector. I think you is already covered in your PD3 science. So you still need to know and recall back whatever that you have learned before, right? I do believe that SPM we will ask also, right? So just be careful, right? So don't everything that you learn is you straight away return back to your teacher. Okay, so for the in the Google Classroom, I think you noticed already. I already share with you some notes here on my module, right? So actually I modified for my old module, right? So some I already added according to the new requirements of the KSSM. Okay, but some I still remain even it's already not highlighted in your new syllabus, but I still remain inside so that you can learn more complete picture regarding the content that you study. Right. Okay. So the 6.1 radioactive decay. Okay. Radioactive decay actually you need to study about the three different radiations. Right. Three different radiations. Before that, okay, you should understand that radioactive decay actually is just the limitum and the spontaneous process. Okay. So so refer to my module, huh? Right? Okay. So there are a few terms here you need to clarify, okay, before you confuse. Maybe you can write down to highlight about these three terms. Okay. First one is about the radioactive. Second is the radioactivity, and then last we have the radiations, right? So radioactivities, and the radiations. Okay, so radioactive, we're talking about the unstable substance, unstable nucleus. Okay, the substance have the unstable nucleus. That's what we call radioactive. Okay, for this unstable nucleus, they will undergo the one's activity because it's unstable. So they will undergo one activities we call radioactivities. Okay, once they undergo this radioactivity, so they will have disease. Okay, they will have this uh, three different type of the radiations, right? So all this process we call it uh, radioactive decay. Right? Because of the radioactivity, they will have the radioactive decay, and we have when during the radioactive decay, there will be three different type of radiation will be released, right? So first one is the alpha particle, okay, beta particle, and the last one is the gamma ray. Right. So when you study radioactive decay, you focus on the study about these 3 different radioactive decay, all right, for the latest syllabus. As you can go through the textbook, okay, textbook will be straight to the point. Okay, will straight to the point. So my advice for you is you may study the textbook first, then only you study the module will be easier for you. Okay, and this radioactive decay, right? This radioactive decay, we said that the process is a random and a spontaneous, okay, because there is no any physical quantity can influence it. Right? Example, temperature, pressure, and others physical factor. It's not like let's talk about one example. If you want to let the water turn into the steam, right? Water turn into steam, right? It can be controlled. It's controllable because we know that the water in liquid state want to turn into the steam in the gas state, it must reach the boiling point. So we can control the temperature as long as the water wasn't reach the boiling point, then the water in liquid form is unable to turn into the steam, right? But somehow they will still have evaporation of the water, because evaporations of the water, it can be happen any time on the surface of the water itself, right? So this is the other process, right? So we're not talking about, now we're talking about the whole liquid, the water in liquid state want to turn into the steam totally in the gas, so it must reach the boiling point, right? So this one is controllable. It's controllable, but for the radioactive decay is uncontrollable. It's the random, spontaneous. We said that it's random, okay, because we don't know. We don't know what it will be decay. Right? So until today, right, the scientists still study, still keep studying on the decay process of our radioactive, which is unstable nucleus, right? Nearly every certain interval time, they will found there's a new decay process, so they will record it, right? Okay, and then we call it spontaneous because it doesn't have a timing to tell you when it's going to decay. During the one period of time, if the radioactive want to decay, let's say want to release alpha particle, it just release. They got no any signal to tell you when it's going to decay. So that's why we call it spontaneous, right? So it won't happen, it just happened. Okay. So the alpha particle, beta particle, and gamma ray, first you must make sure that you are familiar with that symbol. Okay, because the symbol also used to write the equations about the radioactive decay. So basically, this chapter, like somehow is likely like you study the chemistry, because we need to write the equations for the element equations. Okay, so there's the equations of an alpha decay. So remember, alpha particle is presented by the helium nucleus. Helium nucleus, right? So this is the one you must know. Helium nucleus presented the alpha particle, which is the 4,2 helium. Okay, 4,2 helium is the one to presenting the alpha particle. You must know, right? So according to our marking experience, okay, my marking experience in SPM, okay, also in the for the student respond during the exam, okay, even there's very basics, but we notice that when the student are unable to score this question, it's just because it's very simple. Just because they don't know the alpha particle presented by 4,2 helium, which is presented by the helium nucleus. So means that this student, they are not trying to study at all. Right? It just like happens the day I show you lah. Okay, our connection of type of circuit just only have a series and parallel circuit. But during the exam, we do have the student answer. There's what we call it, single circuit and the combined circuit, is it? Right. So this one obviously showing that not study at all. Right. Okay, not even focus during the class. Or maybe the student didn't come to school, I don't know. Right. Okay. So when the very basic question, open book study, straight away no, but you don't know, means that you are not care or not prepared for the exam at all. Right. So it's very basic knowledge that you don't even know. I'm not talking about understanding, I'm talking about what you should know. You should know that, like this one, you should know alpha particle presented by helium nucleus. Right. Okay. So inside the helium nucleus, it consists of the 2 proton and 2 neutron. 2 proton and 2 neutron. So this one, last time we do have the content in our old syllabus. We do have a content to cover the most basic thing that you learn in chemistry, which is we need to introduce again about the proton number, nucleon number. But now all this removed us already, right? We even need to showing that the chemical symbol for the element X, how we write in the equation. All this actually is a chemistry, right? So it's the most basic in the chemistry, so you should know already, right? But I noticed that still have a student having a problems to mention wrongly about the terms, right? So maybe I should check with you first. Okay, if I mention is it the proton number same as the numbers of proton? If you say yes, please raise your hand. Proton number, is it same meaning as the numbers of proton? Yes or no? Proton number, same meaning as numbers of proton. All right, so most of you agree. So down your hand. All right, so next. Is it the nucleon number same as the number of nucleon? Is it the nucleon number same as the number of nucleons? Right. So, all right. So far so good. Okay. Because actually, what? Which one is correct? Number of nucleons, correct or not? If yes, please raise your hand. Nucleon number? Alright, okay, so alright, okay, good. Alright, so at least you know the differential. Because when we said that the nucleon number, the term itself, nucleon number, this term actually is a name. It's a name. Right? So just like the proton number is a name. Right? Okay. So number of proton is to want to know how much the proton that we have. That's why we call numbers of proton. But the numbers of nucleon is wrong because we got no such thing that the particles or the anything that we call it nucleon. So that's why we cannot tell you how many numbers of nucleon I have. No, nucleon number is a terms, is a noun to let us know what, to let us know that, okay, which is what is the total numbers of proton and neutrons. Is together how many proton you have, how many neutron you have, add up together, we call it nucleon number, right? Okay, so help me to admit is someone using the not the MOE ID. All right, okay, so I think this is quite clear already. All right, so now we're going to focus on how we're going to solve the problems to balance the equation, to knowing that how much of the alpha particle, beta particle, gamma in the beginning this all decay, right? Okay, so if this example for an alpha decay, so alpha decay, okay, you can as an explanation given here, right? During alpha decay, an unstable nucleus release an alpha particle to become more stable, right? To become more stable. Okay, all the radioactive decay is to the objective is to let the unstable nucleus become more stable, right? So, but it will take time. Right, it will take time. Okay, because once that decay, so that the unstable nucleus, or we call it parent nucleus, it becomes daughter nucleus, and this daughter nucleus will become smaller and smaller. Right, first when they release alpha or beta decay. But when they release gamma ray actually it wasn't changed the size. It wasn't change the size of the parent nucleus because gamma decay it just only release the energy. Okay, because gamma actually is an electromagnetic wave. Okay, it's an electromagnetic wave as you learned last year. Part of the electromagnetic spectrum, which is the highest frequency one, is the gamma ray. Okay, so why it doesn't change the size of the parent nucleus, but it still may become more stable? Because of the energy. Okay, when it releases a gamma ray, it will reduce the energy in the parent's nucleus, become the daughter nucleus become less energy. Once the energy become less and less, so at the end it will become stable, right? So but the process take really long time. So that's why in our explanation, we just only said that the radioactivity is a activity or is a process to let the unstable nucleus or to let our radioactive become more stable, right? So there are the three different decay here: alpha, beta, and gamma. Okay. So once it release an alpha particle, it will become more stable, and then after that, so this more stable nucleus actually is a new element. So new element we call it the daughter nucleus, right? Okay. So there's just an example in the diagram given here. Okay. So one thing that you should know here is when during the alpha decay, how much a change on the proton numbers, how much a change on the the nuclear number, and also the number of neutron actually. Right. So, but here it seems like they are not focused on the neutron, okay, because just focus on the balance of the equations. On the balance of the equation itself, you can see that, okay, the nuclear number, it will be going to -4. From 210 become 206, so it means it's -4. Because the -4 here will be goes to this alpha particle. All right. And then the proton numbers here, okay, from 84 become 82 means that you have -2. -2 because what? You need to give it to the helium particle so that it can release an alpha particle, or we can release one helium nucleus. Okay, so that's why the nuclear number and proton number were -4, -2. Okay. At the same time, you should understand also, for one alpha particle decay, it will reduce 2 neutron as well, right? It will reduce 2 neutron. Okay, because the nuclear number -4, which is A -4, this -4 is consists of the neutron and proton. So proton we already know that it's -2. So that's why another -2 will be go through neutron. So that's why here it told you from the beginning, 2 proton, 2 neutron. Okay. So why I have to highlight this part, because some question is really tricky, right? It wasn't asked about the nuclear number change. It will ask you about the neutrons on it. So when you careless, okay, you just look at the end and then you study carefully about the questions, so you will get the wrong answer. So this type of question, please, when you study, please be alert, right? Study slowly. Make sure you know what is the need by the questions. Okay, so this one just a balance equations, just a primary school mathematics. Nowadays you can say that it's a kindergarten school mathematics because just a plus and minus. Okay, so next one we have alpha particle here, beta particle, beta decay. Beta decay, so the beta particle actually is a fast moving electrons. It's a fast moving electron. So the electron presented in the equation is a 0, negative E, right? Because the electron is a negatively charged, so that's why the proton number is -1. Okay, and it wasn't make a change of the nucleon number. It wasn't make a change of nucleon number, but because of the proton number +1, okay, proton number from the parents nucleus become daughter nucleus here is +1. So +1 means that there's a change of proton number. So, but the nucleon number remaining unchanged. Nucleon is a proton plus neutron. So, but now the proton is +1. So, it means that the neutron must be -1. That's why this sentence told you that during the beta decay, a neutron in an unstable nucleus is decomposed. Is decomposed into 1 proton and 1 electron. Right? So 1 electron released, and then the 1 proton, so it will be changed on the proton number of the daughter nucleus. Okay, so that is about the beta particle, right? So nucleon number remain unchanged, but due to the increase of the proton number, so it will be decrease the neutron. So then this neutron we said that is decomposed into the 1 proton and 1 electron. Okay, gamma ray, as I mentioned just now, gamma ray is just a high frequency electromagnetic wave, right? So during the gamma ray decay, unstable nucleus will release excess energy to become more stable. Right. So but this gamma ray doesn't have the mass and just a neutral. There's not carrying any charge, so it wasn't affected. It's because it's not carrying any charge, so that's why it wasn't affected by the electric field or magnetic field. All right. Okay. So anyway, during this radioactive decay, some nuclei can emit more than one radiations. Right. So, but example like the uranium-234. So the nucleus will emit alpha particle in gamma ray. Okay, so that is a part that confusing the students in the old syllabus. We're talking about the use of the radioisotope. Okay, there is a wrong concept given in the some of the questions before, right? Yeah, so later got time we talk about that. Okay, because uh when uh when during this emit more than one radiations, right? But the problem is in our equations, in our study to the experiment, we only able to detect alpha or beta particle. Gamma ray we are unable to detect. Okay, gamma ray is just a release of energy, so we only can study on the energy release. But when we use a detector, most of the detector is just only tell us about the result. Okay, result for the alpha and beta decay, it will be clearly shown by the detector. But for the gamma ray, we only can detect by the GM tube. So GMT was showing the energy level of the radiations or the nuclear energy. So from the GMT result, we're able to know, okay, whether there's a gamma ray release or not. All right. So there is also one of the reason make the radioactive is actually really dangerous. Okay, especially when it have the gamma decay, right? So when doing this process for more emit more than one radiations, right? So we have the two way to show. Either we still write in the decay equation as given, or either we write it in the simple decay equations as showing here. These are simple decay equations right here. So from this parent nucleus become daughter nucleus, during this process, what is decayed here? Right, we can write it with a symbol. Right, there's a simple decay equation. This simple decay equation is really important, especially for the decay series. If you look at my module here, right? So we have the decay series here. Okay, from the one plutonium K241, okay, is in to become more stable, right? So it will go through different decay process from the one parent become the other daughter. This daughter become parents, and then suddenly after that another decay will become the another daughter nucleus. So it will continue. Okay, but all the process will take different timing lah. Right. So once during this process, then we have the decay series lah. Okay, so the question will be designed according to the decay series like this to ask you how much is the total number of the alpha particle decay, how much numbers of the beta particle decay. So usually you focus on these two. Gamma ray, there is no, so far because gamma ray is just an energy, so we don't design the question to ask you whether there's called gamma rays or not. Okay, we only design the questions for the alpha and beta decay. All right.